Good morning, everyone. Hope you're having a wonderful May 22nd. I hope that everybody is doing well this morning. I just wanted to thank you for your time. We're going to be talking about a Lokring and what they can do. We're going to have a different. I'm trying different things because we don't seem to be getting all of the people in here that I really think we need to have. Um, if this presentation is for Lockring with R600. I mean, if I've said it once, I've said it at least 1,000 times. Um, I'm not going to use a torch when it comes to R600. I'm not going to. I'm going to. It's not a matter of when it's going to happen. I mean, if it's going to happen, it's a matter of when it's going to happen with R600. With all of if I'm releasing R600, which is a highly flammable gas, um, or you could bring it out in a liquid form. Once again, it's highly flammable, and you're going to end up with a whole lot of pain and suffering that you don't need to be doing. So one of the things that we're going to do today is we're going to go back and we're going to take a look at the safe handling of the refrigerants. Okay, so let's go ahead and let's get started.
Hello everyone, I'm Jeremy Hedges with American Vulcan Corporation, and today we'll be reviewing safe handling of flammable refrigerants. In this case, R600A, which is the refrigerant contained inside of our Sub-Zero under-the-counter refrigerator that we'll be working on today. We'll be utilizing our American Vulcan charging kit to both extract and to charge the hydrocarbon refrigerants back into the system. As you all know, hydrocarbons have become very popular refrigerant of choice from manufacturers to meet environmental impact requirements. The R600 we'll be dealing with today has an ASHRAE 34 classification of A3, meaning it's A for non-toxic and 3 for highly flammable. And keep in mind that all hydrocarbon refrigerants are going to be classified as A3 refrigerants. Some other common refrigerants that you'll deal with that are flammable will be R32, R452B, R600, as we'll review today, and also R290. Most of these refrigerants are going to be seen in the commercial aspects, and R600 is what we'll see in residential refrigeration. And that's pretty much what our American Vulcan charging kit has been designed to handle. It's going to be anything with R600 for residential appliance. As I mentioned during my introduction, today's focus is going to be on the safe handling of flammable refrigerants. In this case, the refrigerant is inert when it's inside the system because it has no oxygen in it. We need three things to sustain a flame. We're going to need fuel, which in this case, the R600A. We'll need air, oxygen, and we'll need an ignition source or a flame. Sudden release of the refrigerant from a cabinet or from an appliance could result in flash fire, a sustained fire, or even an explosion. The most risk is contained in an internal leak inside of the cabinet, where the gas could actually be introduced into the air that's already contained in the unit. And if an ignition source was present, that could be the potential of an explosion. Keep in mind that it's a very small mixture, a small ratio that we have to hit in order to create this flammable environment. It's referred to as our lower explosive limit or lower flammable limit. In the respect to R600, it's a 1.8% concentration limit, meaning we need 1.8% of the R600 to combine with the remaining oxygen in order to promulgate a flame. If we get to our upper explosive limit or upper flammable limit, which would be at an 8.5% concentration level, we actually have too much fuel to promulgate a flame. So just like I mentioned inside of our system being pure R600A, theoretically, it can't ignite until we introduce air. A technician can do that by cutting into the system and allowing air to be introduced. So just like with our traditional refrigerators and appliances with our standard refrigerants such as 134A, all the regulations associated with hydrocarbons will be controlled through the EPA and SNAP regulations. One of the big changes that you'll see is no retrofitting. In a case of a retrofit, you may be taking a 134A refrigerator and trying to convert it to an R600. Keep in mind, this is currently illegal. And the reason for it is that the R134A refrigerator won't have the intrinsically safe devices like timers and switches that are commonly used with flammable refrigerants. So you could inadvertently convert a refrigerator and it's chocked full of flammable or ignition sources that could present danger to both you as a technician or the homeowner themselves. There are some changes, however. You're going to see a lot more warning labels all over the appliance, including some R600 labels by the compressor. You'll have labels by the evaporator and also on the outside of the cabinet. These labels are meant to allow the homeowner and the technician both know that there's risks associated with this refrigerant. As a technician, there are two really good resources that you can use for additional hydrocarbon safety tips and guides. The first is AHAM, the Association of Home Appliance Manufacturers, and RSES, Refrigerated Service Engineering Society. AHAM has written an instruction for appliance technicians on recommended methodology on how to handle R600 and other hydrocarbon refrigerants, and would highly recommend that you take a read. RSES's textbook on hydrocarbon safety is filled with tips and tricks on handling hydrocarbon refrigerants safely, as well as all of the charge limits for all of the equipment available and dictated through the EPA. At this point in the presentation, we'll be going through our pre-safety check that is in alignment with our AHAM guidelines. The first thing we'll want to do is ensure what type of refrigerant we have in the appliance. In this case, it is R600A, which can be verified on the manufacturer's label plate. We'd also want to have on hand the MSDS associated with that refrigerant in case we need to render any first aid. The next very important piece that's going to help the technician monitor the environment is going to be a combustible leak detector. This leak detector will be used initially just to search for leaks on both the inside and outside of the cabinet. And then we'll continue to leave this leak detector on to monitor the environment as we service the equipment. Next important piece is going to be a fire extinguisher. Just in case we have an incident, we want to be prepared and have firefighting equipment on scene. Another component that we're going to be utilizing is a tube cutter for the removal of all of our tubes. We'll no longer want to use a torch since this could be the ignition source that would promulgate a flame. The other portion we want to consider is maintaining a well-ventilated area. We're going to do this today by introducing a floor fan that's going to help bring fresh air into the environment and prevent us from ever reaching the concentration of our lower explosive limit. This should help mitigate any flame should we have a leak in our system while we're working on it. And finally, we're going to want to eliminate all of our ignition sources. Some of the obvious ignition sources that we have could be a homeowner who smokes, matches, maybe they have candles throughout the home. The torch itself, the spark lighter you're using to actually ignite the torch, all of these would be very obvious ignition sources. But the first tool we grab as a technician is often a cordless drill. If we hadn't done that pre-safety check with our hydrocarbon leak detector, we may not have noticed that there was actually a pool of gas inside that cabinet. And as soon as you hit the trigger on that cordless drill that's a brushed motor, that could be an ignition source. So that's where we're talking about. Some ignition sources are not as readily apparent as others. So keep in mind, do you have an intrinsically safe tool that you're using? The vacuum pump itself, is it rated to actually work around flammable refrigerants such as A2L, A2, and A3 refrigerants? Now we're moving into leak detection and line repair. And through following AHAM guidelines, we're going to start with only using a tubing cutter to remove any of our tubes. Like I mentioned previously, the torch is going to be considered an ignition source, so we need to move away from that and simply cut all of our tubes. We want to use a certified leak detector, preferably an electronic leak detector when trying to identify these leaks in the system. Keep in mind that R600 on the low side runs in a vacuum while it's running. So if you use soapy bubbles or some type of external fluid to detect leaks, this could be drawn into the system if the system has a significant leak on the suction side. So please keep that in mind that before running a system, you would want to clean any of those soap bubbles away from the suction side of the system. You can also use dry nitrogen to pressurize the system and to create almost a trace gas using the R600 that's in the system. One of the big benefits of working with hydrocarbon refrigerants is now to find a leak, we can just add nitrogen immediately to the system to raise our pressure to around 100, 110 psi to facilitate the use of an electronic leak detector. This should allow us to, in a more timely manner, identify the leak. In the past, we had to recover the refrigerant if there was any remaining, and then add a small trace amount of the refrigerant along with dry nitrogen. We can now eliminate this step because R600 can be immediately released to the environment after we're done with our leak check. One of the major aspects that we want to continue to monitor while doing our sealed system service is going to be constantly monitoring for a flammable environment. We're going to do this by using our electronic leak detector, leaving it in the on position while we're performing our service. If we get a leak, this should start to alarm and allow the technician to know that something has happened to change the environment and that it potentially could be flammable. As we continue with the leak detection and line repair, at some point we're going to have to remove the gas from the appliance. In order to do this, it's much easier to directly discharge the gas straight into the environment by using our discharge hose and routing it through a window or a door. If this isn't an option, then using a temporary container such as a recovery bag or maybe even a recovery cylinder would be more appropriate. Keep in mind that if you use the bag or the cylinder for temporary storage, you want to discharge this immediately in a fresh air environment that is free from any ignition sources. Another component we want to stay away from is compressed air. Just like with our traditional refrigeration systems, we're not going to use any compressed air or oxygen for flushing the lines or blowing away debris or cleaning. Keep in mind that pure oxygen is an oxygenator and can be flammable in the right circumstances, and especially in introduction of petroleum-based products. Always use dry nitrogen if you need to flush your system. There are red marks that are going to be located near the process tubes on the appliance. These need to be maintained on the system. Some manufacturers use heat shrink sleeves, others will use actual paint to indicate that this is a flammable refrigerant inside of this system. So it's just an additional warning or visual indicator for the technician that there is indeed flammable refrigerants in the system. Always remove your piercing valves. This hasn't changed. Even with HFCs and traditional systems, you're always supposed to remove your piercing valve after service. They're always going to be a potential for leaks and should be removed and filled or the tube repaired after this service is completed. During the refrigerant removal phase of our service, we're going to want to ensure that we maintain ventilation. Again, having that floor fan or an intrinsically safe fan nearby to bring fresh air in will greatly prevent us from ever achieving that lower explosive or lower flammable limit we talked about previously. We want to maintain our proper grounds once again, and of course verify that we are using a refrigerant that is legal to discharge into the environment. If you're using R32 or R452B, you're going to need to actually recover these since they are HFC refrigerants. If you use a temporary vessel, such as a recovery bag or a recovery cylinder, you do need to ensure that you empty this before you transport it anywhere. There's no point in putting a full recovery bag or full recovery cylinder filled with a hydrocarbon refrigerant that is no longer useful. Just simply discharge that into the air in an area that is risk-free and free of any ignition sources that could potentially ignite the gas. And of course, if you're using your equipment, hoses are going to be a big part of this. We're going to have quite a system of hoses. You want to ensure that they are all compatible with the refrigerant that you're using and are adequately long enough to either discharge outside of the home or to reach whatever recovery device that you're using. In recharging and replacing refrigerant inside of an appliance, the first thing we're going to want to do is match the refrigerant type. Again, as mentioned previously, this will be found on the manufacturer's label plate. In this case, we're doing R600A, and it has a charge quantity of 1.2 ounces. So obviously a very small charge. You'll see that there are significantly smaller charge volumes when dealing with R600 than you previously are used to with traditional HFC refrigerators such as a 134A refrigerator. We want to ensure that all of our electrical faults or problems have been repaired and placed back into operable condition before actually accessing the sealed system. Remember, anything electrical could be an ignition source, so let's repair that from the beginning, and then we can move to our sealed system repairs. Keep all our grounds in place, and make sure that as we're cleaning up or if you're accessing lines that you don't use any corrosive cleaning chemicals such as ammonia or bleach that may impact the actual service life of the copper tubing. It can degrade that over time. So try to avoid those cleaning products. And finally, we want to ensure that we renew and tighten any seals in our system. For most residential systems, the only real seals we can access are going to be the Schrader cores that are in the process tubes. It is appropriate to torque those down. You can buy a small torque wrench that will actually torque the cores to the recommended specification. And finally, once we've completed all our service, repairs, and inspection of the appliance, we want to make sure that all of the safety labels are still intact, and of course also the red markings on the process tube. You can again use heat shrink to place over the tube to indicate this, or use epoxy paint. The installed ventilation features, you must remain intact. A lot of technicians don't understand that piece of cardboard is the true ventilation system on the back of that refrigerator, that it helps to direct airflow across the condenser and across the condensate pan. This is also one of the locations where R600 could pull inside that condensate pan. If you had an inside the cabinet leak, you could literally come down the condensation drain and collect inside the condensate tray and remain there for some quite amount of time. R600 is a very heavy gas, and therefore can be still in either a deck drain or a condensate pan. Any of those locations could house some refrigerant that leaked either from the service that you performed or a leak that was in the appliance previously. Another thing to note is when you are getting ready to open a sealed system is that just because you've recovered all the refrigerant doesn't mean that there's still not refrigerant in the system. Up to 50% of the refrigerant charge can remain emulsified in the refrigerant oil in a system that's been inactive for a long period of time. Couple that with lower ambient temperatures, and you can see even more of a charge remaining in the oil. So keep that in mind during your service process. So we're getting ready to unbox our American Vulcan charging kit, also known as our US charging facility. We're going to go over all of the components contained in this kit that are going to help technicians safely perform a charge and recovery of any flammable refrigerant that you may encounter on a residential refrigerator. So the first component we're going to talk about is the actual discharge hose that comes with the kit. It's actually strapped right to the lid of the kit, and this is for the removal of refrigerant when you can discharge outside of the home. You could either route the weighted end of the hose outside of a window or through a door. Just be sure to always verify that the area where you'll be discharging the refrigerant is free from any ignition sources or high traffic. Next component we're going to take a look at is our electronic scale. Our scale has resolution available in grams or ounces so that you can easily convert in the field to whatever resolution or scale is used on the manufacturer data plate. Next component that we're going to discuss is the 4 accessory hoses that come in the kit. And those are utilized to join both individual single valve manifolds into one manifold assembly, simulating a 4-valve manifold assembly. Next component we're going to talk about is our low side manifold gauge. This gauge has a much higher resolution on the vacuum portion than your standard R134A gauge. The maximum pressure on this gauge is 45 psi, so be very careful. If you hook this to a 134A system, there's a high likelihood of creating an overpressurization and permanently damaging the gauge. Next component we're going to take a look at is going to be the high side manifold gauge. This gauge has a maximum pressure of 140 psi. So if you hook this to a 134A system that is in operation, you have a high risk of overpressurizing the gauge and permanently damaging it. Also, for mounting to the manifold sets, we do have 2 mounting hooks that will easily thread to the back of the manifolds, and that will allow you to conveniently hang the manifold sets from the appliance that you're servicing. The next component we're going to take a look at are our Schrader core depressors. It's a very handy tool that can conveniently turn any process port into an open and close valve. Also included in this kit are 2 ball valves. One ball valve has a 1/4-inch SAE male and a 1/4-inch SAE female connection port. The other ball valve has 2 male 1/4-inch SAE ports for easy connection to your standard refrigeration hoses. The next component we're going to discuss is our bottle adapter. This is used to adapt our R600 refrigerant cans to a 1/4-inch SAE flare so that we can hook our refrigerant hoses to it. Please keep in mind that the adapter is made from aluminum and the can has steel threads, so be very careful when you're threading the adapter onto the bottle. We also have 2 T's included in the kit. One is for the adapting to our liquid charging stand, while the other is utilized to create a small manifold, which will allow us to both evacuate the system at the refrigerant bottle and the appliance itself. We also have 2 more longer hoses that are installed in the kit. They'll be attached to a check valve. This check valve is designed so that during the charging process, refrigerant can't flow backwards and back into the can. Please also note the directional arrow that's on the check valve. This is very important that the arrow should be pointing away from the refrigerant bottle or away from the source of the refrigerant that you're trying to charge into the appliance. So we've completed our review of the AHAM recommended procedures for handling R600 and other flammable refrigerants. So the first thing we're going to get into with our hands-in process is actually start our preliminary check. So we have our locator, which is a TLD 500, which is produced by Vulcan. This is our refrigerant leak detector, which also does detect hydrocarbons. So this is an all-in-one. It will go through a warm-up process that will take a brief 30 seconds or so, and then you'll hear indicated by a tone that it's actually functioning. Preferably, you'd like to take your electronic leak detector out to a fresh air environment to calibrate it. Obviously, here in studio, we haven't had a sealed system open yet, so we do know that it is a fresh air environment. So we'll allow it to calibrate here. So as we get our pulse, the TLD 500 will announce a constant chime as it's powered on. So this becomes our indicator that our environment is free of any hydrocarbons and we're not at risk of reaching our lower explosive or lower flammable limit. So I'll internal to the cabinet. So back by the vents where our evaporator would be located. Just make sure you don't get any continuous tones from the leak detector. With a lot of airflow, because the unit's running, you may get a couple fluctuations, but as long as we don't get a continuous tone, it should be free of any leaks. Focusing around the evaporator, come down to the condensing unit. Keep in mind with R600, it is a heavy gas, so predominantly it'll be found near the bottom of any of your components. I'm not getting any indicators on my leak detection system, so I'm going to let it continue to remain powered on. For video purposes, I'm going to go ahead and silence our locator just to not have the beep. I would highly recommend when you're performing your real service that you leave the beep audible, so it's not something you have to look at periodically. But to silence it, I just push the silence button here. And I'm just simply going to place it down on the table and allow it to monitor, placing the sensing probe near our work area so it can monitor for any discharge of R600A gas.
All right. So I hope that you enjoyed that presentation. That's a little different than the one that I had done myself over the last several times. Like I said, I like to take and try to freshen things up a bit. There is a part 2 on this. So let's just sit back and recap what was discussed today. I mean, number one, we always know that there's 3 elements that have to be present for me to get a flame. I have to be able to get. I have to have oxygen. I have to have a type of like gas that would be flammable, and then I also have to have the air source that's going to be the ignition point, which could be your give me a second here. It could also be like he was saying, your drill. So once again, one of the things that as a technician, I want to be sure that I'm doing is if I can find myself anything that's brush less, I'm going to invest in that, because with R600, it could be the ignition point and cause my issue. I have seen a couple of videos. I had a friend send me just a picture of one of their technicians' hands, because they actually did not heed what the same thing that I keep telling everybody: don't use a torch. They used a torch. There was an ignition point, and it burned the technician's hand. So that's one of those are several of the things that we want to make sure of. We're going to actually go and we're going to go ahead and kind of go down to the second part of this. Um, and we're going to go ahead and keep moving on along. So let's go ahead and go back to that. Give me just 1 second. Share screen. Now here comes the fun part. There it is. Ready? There we go. We're going to start right here. And hold on. If you have questions, let me know. Let me know and write them down so that we can go through it.
As you can see, previously we've already have process stubs mounted to this piece of equipment. In the field, it's probably going to come with crimped off process tubes. For training purposes, we already have the process tubes on. So we have our suction process tube and our discharge process tube off the dryer installed, as indicated by our red tape. We know that there's flammable refrigerant inside this unit. So the first step will be to discharge the refrigerant. If you have a compressor that is functioning and working, we recommend that you warm the unit up for about 5 minutes prior to starting this process. That'll help to break the bonds between the refrigerant and the oil and allowing you to get more of the refrigerant out of the system during the discharge process. If you're just replacing an evaporator or a component and you can run the compressor, you can use the compressor to help aid you in the discharge of refrigerant. If it's a non-functioning compressor, obviously the ambient air temperature is all you're going to be able to rely on, and you'll do a passive type of recovery. So I want to make sure that this is all the way back seated. It even says open close on the back of the valve. This will prevent us from installing this and the Schrader core being depressed. So all I have to do is go ahead and run my core, get it nice and snug, and then the system's ready to go. The Schrader core is still closed. Obviously, no refrigerants coming out. We're not indicating anything on our leak detector. We can go ahead now and hook our discharge hose up. Again, if we were discharging to the exterior of the home, this is our discharging hose, which comes with a weighted end. We can go ahead and hook directly to the unit, run the hose outside, start the compressor, and start the discharge process. In this scenario, we'll be using a standard accessory hose, and we'll be charging to a recovery bag. So the first thing we'll do is we'll lay out our recovery bag that we'll be using today. Obviously, with recovery bags, they're temporary recovery cylinders or bags in this state. The bag does need to be inspected. So periodically, you do want to check the bag to make sure that there's no rips or tears in it. This is a double line bag, so it is very durable. Go ahead and hook into the bag, and we'll leave our valve shut. And again, a valve isn't necessary, but I prefer to have anytime I can have a quick access shutoff valve, I prefer installing them. So I do keep that on my hose. It lets me isolate to the bag quickly. So we're going to go ahead and thread in our Schrader core depressor. This will allow my refrigerant to flow to the hose up to my valve. And after I open this valve, you're going to hear the refrigerant start to discharge quite rapidly into the bag. That is one thing I like about utilizing a recovery bag, is because you can hear the refrigerant and essentially the state of emptiness of the refrigerator, so to speak, just through the auditory tone. So it is helpful once you become experienced as a technician to listen. So I'm going to try to be quiet for the remainder of this portion so you can actually hear the refrigerant flowing. All the way front seated. And then as soon as I open this valve, we should start to hear the refrigerant flow. Now that you can barely hear the refrigerant flow, this is usually where I'll close my quarter turn valve and I'll let system pressure kind of build back up a little bit. Since we still have the capillary tube not pinched off, there's still a little bit of a Venturi effect, meaning the refrigerant will flow through the system, through the capillary tube, and take some time to build pressure up. So as I open my quarter turn valve again, you'll hear another sudden surge as pressure has built up in the system. And then I'll shut it again. And I'll continue to do this a few times until my system no longer discharges. Now, to aid in this, since we have process tubes on here, we could attach our suction gauge and monitor our suction side pressure as well. But as you get experience with using the recovery bag, a lot can be told just by the auditory. So here we go again. I'm going to open the valve. You'll hear another discharge. The other thing you can do while you're discharging is you can reach into the unit, tap the compressor a little bit. That'll help free some of that bond between the oil and the refrigerant. There's our capillary tube. So normally we'd take our pinch off pliers if we were going to actually replace the dryer, and I'd simply come into the cabinet and I would just pinch off the capillary tube. That'll direct all refrigerant flow through my hose and into the recovery bag. If we pinch it off, it can no longer go into the system. It has to come through the process tube, through our Schrader port depressor, through our charging hose, and into our recovery bag. So once I open this valve again, you should hear another discharge since we haven't been discharging the bag for a little bit. And as you can see, it continues to get less and less and less as we discharge the unit with the aid of the compressor, getting to the point where I hardly hear anything at all, which is telling me as a technician that it's safe to go ahead and stop the recovery process and go ahead and open up my system and perform any component replacement that I need to. Again, as an added safety to technicians, especially one that is new or isn't using a recovery bag, you can always hook your suction gauge up to the suction port and monitor the suction pressure to ensure we're getting to zero or into a vacuum. If you would like to hook a suction gauge up, we already have a service port here, so we can always monitor our system pressure by hooking our suction gauge manifold. Now keep in mind with R600, if we weren't actually recovering, I would not want to hook this gauge up because again, R600 is on a vacuum on the suction side. If I hook this to a functioning system without evacuating my manifold first, I would basically suck all of the air and non-condensable gases directly into the system. So keep in mind, for troubleshooting purposes, you will need to evacuate your gauge set before you ever hook it to the low side of the system. So I have my suction gauge manifold all hooked up. Our suction hose goes to the bottom of the gauge manifold. And I'm not going to use a Schrader core depressor, but I do need to ensure that the hose has a Schrader depressor installed so that I can actually get a reading. And you can see the gauge instantly fell into a vacuum. And that's what I was saying. Even though I didn't have a gauge up, I was confident that we'd removed the refrigerant just by the sound it's making in the bag. And of course, that's going to come with some experience. So until you get that confidence, go ahead and hook your suction gauge up. It's not going to hurt anything. We're recovering the unit. Any air and nons is going to be sucked into the system and discharged into the bag. We'll perform our service and we'll evacuate everything anyway. But this gives you that extra safety of knowing what the system pressure is. So our unit's back on and running, and you can see it's starting to pull down even further into a deep vacuum because there's no refrigerant left. Almost down to 29 inches. So the compressor is in great shape. And one more time, we'll go ahead and do a discharge to the bag. And you could hear nothing, which is obviously indicated by the gauge. We would expect to hear no more gas discharge. But that is basically the complete discharge and recovery of our R600. So at this point, I'll leave my valve and hose assembly attached to the bag. I'll simply back seat my Schrader core depressor, and then I can safely disconnect the whole assembly. With this whole assembly now disconnected, I have no fear of loss of refrigerant. I can take this bag outside into a safe area that's free of any ignition sources and discharge the R600 into the atmosphere. Okay. So here we are outside. We've come to a safe location with limited foot traffic and no ignition sources, so it's safe to go ahead and tear down our recovery bag. So the first thing I'll do is remove my hose, and I want to open any of the valves just to make sure that the R600 can flow freely through the hose. Then the next step I'm going to do is I'm going to need to remove the Schrader core that's in this bag. It's there to prevent the refrigerant from discharging out. So I'm just going to take a Schrader core removal tool, and it's actually a torque tool as well. And I'm just going to simply remove the Schrader core. And then remove the core. So I'll just turn the bag over. Again, remember, refrigerant's heavier than air. And just start rolling it up. Something to note while we're getting the refrigerant out too, that the bags only hold just over 12 ounces. It seems like a really big bag, but it doesn't hold a lot of refrigerant. The whole key with a recovery bag is that it should never become pressurized like an actual recovery cylinder. So do pay attention to the volume of the recovery bag that you're working with and how much charge is in the appliance. We just want to get as much as we can. I do regular maintenance every now and again. I will put our bags under a vacuum just to pull everything out of them, and also to ensure that there aren't any holes or leaks in it. It's a pretty effective way to leak test your bag, since you don't really want to pressurize it, since you could just weaken the joints. And that's it. So we're at the point now, we've done our preliminary checks. We've gone ahead and recovered all of the refrigerant from our appliance. So now we're getting into the actual charging. So we've replaced our components, we've installed a new filter dryer, and we're going to go ahead and charge the system. Before we do that, we're going to need to at least get our entire hookup of our charging kit, and then we're going to do an evacuation so that we can test all of those connections. So we'll open up our kit. First thing we'll do is we'll get our low side gauge out. And we'll take the hook and we'll go ahead and get it installed. I'm just going to mount it here for now. So just like a typical gauge manifold, the bottom port is the port that connects to our appliance, and any of the side ports is for the transfer of refrigerant, or it's for hooking to the other gauge. Now, quite often technicians only want to use one gauge. If they're not troubleshooting, they're simply going to be just recovering or charging. They may only want to use the one gauge. If you know the system has no restrictions and you just did work on it and it's maintenance, you could only do one hookup. But today we're actually going to hook both the low side and the high side up so that you can see how to deal with the liquid refrigerant that will get inside the gauge manifold for your high side. All of that refrigerant does need to go back into the system. Remember, R600, it's very small amounts of refrigerant, and every one of these appliances will be critically charged. So we do need to account for all of the refrigerant going into the system. We do want to notice on this gauge, the resolution on the low side of this gauge is much larger than you typically see for a standard refrigeration manifold. Keep in mind that with R600 running constantly in a vacuum, you want a higher resolution on this low side. The other thing you want to notice is that the max pressure that is on this gauge is 45 PSI. So if you try to hook this to a 134A system, you very well could overpressurize the gauge. So keep in mind that both this low side gauge and our high side gauge are going to be utilized for R600 service only. If you put in, again, the range on the high side, you're looking at 140 PSI, and the resolution for the vacuum is still what you would typically see on a normal gauge that you're used to for 134A. So our kit will come with 4 accessory hoses, and this is for mounting our gauges to one another as well as to the system. And I'll go ahead and I'll grab a Schrader core depressor. I want to make sure that the hose without the Schrader depressor is hooked here. Then we can go ahead and install to the other side of our manifold. And I'll do the same thing with the high side manifold. And I'll hook its Schrader port, Schrader depressor up, and I'll hook to the bottom of that gauge. I do it like this just so that I know instantly where the hookup and which hose goes to the appliance. Some people do color code these hoses. They prefer to have red tape to go here and red tape and then red tape. So it just keeps it easier for them for the hookup. But eventually with practice, you really don't need that. So the next thing we will do, we'll be charging this unit. Since it's only 1.2 ounces of refrigerant, we're actually going to be charging in a vapor, so we'll leave our bottle upright. If this had 40 grams or higher, we would actually need to charge in a liquid because condensation will start to form on the bottle. But since this is a relatively small charge, we'll actually be charging in a vapor today. The next part is our T portion. This is going to create a manifold to help us hook and convert our single gauge manifolds essentially into a 4-gauge manifold set. So all I have to do is hook to our T. We have one double male connection, which will go on the female side of the T. And this will be my evacuation port, and this will become my refrigerant supply port. So this will basically the large accessory port or the 3/8 line that's on a 4-valve manifold and the 1/4-inch line that you typically see on a 4-valve manifold. And then that's what we've recreated. We need to hook our high side and low side gauges together. So there is a Schrader core inside here. So I want to make sure, again, I use the Schrader core depressor to hook to the accessory port on my suction gauge manifold. And then this will just hook to the accessory port on this high side gauge, effectively linking them together. So now this has become just like a standard 2-valve manifold, but we've used a hose to bridge the two together. The next hose that comes in the kit is our charging or refrigerant hose. It does have a check valve installed, and it does have a direction of flow. So we want to make sure arrow is directional flow is this way, which means it's going to flow from our bottle to the appliance. So I want to make sure that arrow is lined up in that direction. And then since we're doing a vapor, come to the back side and I just hook to my bottle. Make sure my valve is closed. And I can simply thread the bottle onto my can. Keep in mind that the can adapter is made from aluminum and the can is steel. So if you just swing this can onto the adapter, you have a very high potential of stripping the threads in your can adapter. So always be careful when you're actually installing the adapter. And again, that's going to hook to the refrigerant side of my manifold. I'm going to come over to my vacuum pump and get my vacuum hose. It is recommended that you put a ball valve on your accessory hose you use for evacuation. That will allow you to secure the valve while the system's under a vacuum, preventing any oil from being drawn into the hose and contaminating your hoses. And I'm going to hook that to the vacuum portion of my manifold. Make sure all the connections are good and snug. And then we have my final connection hose, which we simply hook into the side port of the suction gauge manifold, ensuring I still have a Schrader depressor because there's going to be a Schrader core if it's not been removed on the side. In this case, the Schrader core depressor has been moved to the side. So we still have a Schrader depressor. We're still good to go. So this is the entire hookup of the system. And now I can simply take my high side gauge, which we've already have hooked up. My Schrader core depressor is already attached. The only thing I want to verify is that I'm all the way in the back seated position. So all the way to the left, it'll stay closed right on the back side of the valve. And then I can install Schrader core depressor. Again, the valve core has not been depressed. It's not open to the system yet. It's simply acting as a closed valve. That's the great thing about Schrader core depressors. You basically turn a Schrader core into an open closed valve through the use of this tool. And again, I'll take my suction. So again, making sure I'm all the way back seated on my knob, and we simply install it to our suction side process tube. And there you go, nice and snug. At this point, I'm ready. I have both my gauges are hooked up. Both side valves are secure. I don't need anything going to my vacuum pump at this point, and I don't need anything coming from my refrigerant. So I make sure that all my valves are closed at this point, and we're all hooked up. What I want to do next is check all my connections. Since we have quite a few connections and hoses here, I'm going to go ahead and run my vacuum pump and then set my low pressure gauge pointer to wherever the ultimate vacuum lies. So whatever the capacity of my pump is, should indicate on the gauge. We'll let it run for approximately 5 minutes, and then we're going to shut the pump off and do a standing vacuum or vacuum rise test to see if we have any leaks anywhere. There's no point getting into the system and then determining you have a leak in your hose or your setup. We want to find that right away in the evacuation process, or it could take extremely long amount of time. So that, we'll switch our pump on. I've got a valve on the hose, which is open, so my vacuum is coming through my hose. I'll go ahead and open my manifold. It comes up to my low side gauge. Need to open my valve manifold. You see it instantly drop down to a vacuum. I'm going to do the same thing on the high side. Instantly drop down into a vacuum. Then I'm going to go ahead and open up. We're going to make sure my refrigerant bottle valve is shut, and I'll open my port to the bottle. Not pulling any refrigerant, but I am evacuating all of my hoses up to the point of the bottle. Make sure those connections are snug as well. And when we're at this point, we just want to take basically a quarter turn in on our Schrader removal or Schrader depressors. The reason for that is if there is a small void in here, and when it's fully backseated, there's no vacuum being applied to our last connection, which was the Schrader core depressor to the process tube. By front seating it, I allow the evacuation to occur all the way to this point, therefore testing all of my connections. And then I'm going to set that reference pointer right on top of my needle on the low side gauge. Since I've already established the pump's output, I know that a dry system after time should reflect the ultimate vacuum output of our vacuum pump. And what I'm doing is I'm leak testing all of my connections now. All I have to do is let the pump continue to run, isolate the valve at the pump itself, and make sure we don't get any rise in vacuum. Usually 5 minutes is adequate. If you see no rise, all of your connections are good, your hoses are tight, and you're ready to begin the evacuation process. So at this point, I don't see anywhere where I've had a rise. For video purposes, we're going to cheat a little bit, and we'll advance from the 5 minutes. So we'll go ahead, open our pump supply valve. So now we're pulling vacuum again to the system, and I'll go ahead and open front seat my Schrader core depressors. And we do that a little slow, just in case there was any residual refrigerant trapped in the system. We don't want to slug our vacuum pump. I'll do the same thing on the, well, that was actually the high side, so we'll do the low side now. No movement on the gauge, we're good to go. So both gauges are into a deep vacuum. At this point, we'll do our standard evacuation process, generally about at least 15 minutes. Good indicator on these gauges is going to be our reference needle. It will allow us to know when we've pulled down to a deep vacuum. If we can get to the ultimate vacuum of our pump, we know that this system is fully recovered. If you have a micron gauge, you can always hook a micron gauge to the system, which is recommended, so that you can get a stable 500 microns of dryness in your system. Again, our evacuation will take approximately 15 minutes. and we want to make sure we don't see any rise in the system. Generally, after pulling for about 5 minutes on the system itself, I'll go ahead and do another standing vacuum test so that we can see that the system itself doesn't have any leaks. Because we've done repairs on this refrigerator. We put some Lokring connectors on to put our process ports in. So essentially, we want to test all those connections as well. So I'll do another standing test on the refrigerator and make sure, again, I generally wait at least 5 minutes and make sure that we don't have any rising vacuum. Don't see any rising vacuum, so we'll continue with our evacuation process. And that's done by simply opening the valve back to our vacuum pump and allowing the system to continue to evacuate. Again, the whole time this operation is going, we still have our fan running and we're still monitoring for leaks using our leak detector over here. All of those devices should be in place while you're performing this service. Okay, so we've completed the evacuation process, and at this point we can move forward with the charging of our unit. Everything is going to stay hooked up exactly the same. The only thing we'll change is we're going to go ahead and close our liquid side of the system because we're not going to be charging liquid at this point. So now we can go ahead and secure our ball valve for our evacuation hose and go ahead and shut off the pump. And at this point, we can shut all of the valves on our system. By shutting all the valves, we're essentially saving all of the vacuum inside. We're guaranteed that we're not going to lose our evacuation. We shouldn't have any leaks. So this is the reason I shut all the valves. We'll be charging in a vapor today. We'll have our scale here. We'll zero out our scale. Currently have it set to ounces so that we have 1.2 ounces of refrigerant of R600 needed for this unit. So we'll be delivering it from our bottle through our check valve, which our direction arrow is pointing away from the bottle. So refrigerant flow will be from the bottle towards the unit. And then I just take the check valve and sit it in the kit. And that helps prevent the scale from being moved around a lot. And we can get a more accurate reading. Try to keep it in the same spot. Some technicians actually put a blue or a circle around here so they can keep their cylinder in the same spot every time. And after we moved it, we want to zero it. So at this point, we're able to open our refrigerant bottle and we'll go ahead and deliver the gas through our suction side. So I'll go back and reopen our suction side and our suction side manifold, and then we'll regulate everything from right here as we push our charge in, looking for 1.02 or 1.2 ounces. And once we get to the point where we don't see any more refrigerant being drawn in, we'll actually turn the unit on and allow it to draw the remainder of the refrigerant in. Prior to doing that, I will secure my refrigerant inlet valve and then turn on the refrigerator, which it does have a slight delay, so we'll have to wait for that to kick in. Once that gauge starts to come down, we'll open up our refrigerant flow again. Once we get close to the full charge amount, we'll start to close our valve and meter it in, just allowing the scale time to equalize between little charges. And this will allow us to ensure we hit the most accurate charge we can, which is 1.2 ounces. So we're at 1.0. One.
We get the red one as well.
It won't change right now. Shouldn't be. And we hit 1.2. Now, if we're troubleshooting, we want to see the high side gauge. We'll actually have to get a high side reading, and we'll need to do that by actually opening our Schrader core depressor. So we've hit our 1.2 ounces of refrigerant into our refrigerator. So at this point, there's still going to be refrigerant inside my charging hose, and the blue charging valve is closed. So I need to get this tiered amount of refrigerant into the unit, and that's simply by closing the refrigerant bottle or our bottle adapter and closing this valve. Now no more refrigerant can escape the bottle. So once I open my charging valve, we should see a little spike on the low side gauge, and then the remainder of the refrigerant is pulled in. And we close our valve. And now it's safe to disconnect the bottle from our bottle adapter. So at this point, we've identified that our high side is operating at a correct pressure here. We have 70 PSI on the high side, which is very typical for a small R600 unit. At this point, we're ready to disconnect. So I need to come to my high side gauge, and I just need to back seat my Schrader core depressor. And then remember, there's a void here. So if I fully back seat, I won't get the little bit of refrigerant that's going to be caught between the fitting and the actual stem of the Schrader core depressor. So I'll simply turn it in about a quarter turn. That'll open this area up, allowing me to recover all of the refrigerant. So we'll come through. I'm already tied to my suction side. I'm still reading. My suction side is still open from the charge process earlier. And all I want to do is slowly crack this open and draw all of the liquid refrigerant out of my gauge manifold. It should essentially match my low side gauge. Once we're in a vacuum like this, I can simply backseat my Schrader core again. I can isolate my valve manifold, and I can remove the Schrader core depressor safely. Always put your Schrader cap back on if you're going to leave the process stubs in place. If you want to permanently leave these in place but render them useless to a homeowner or another technician, or for R600 liability and safety, you can always put some lock prep into the end of the Schrader core and onto the threads and install the Schrader cap, and you have just rendered that port unusable and would be just as good as if you would put a stopper on the end of the process tube. If you like to leave the Schrader cores here for future services, that would be up to your company policy. I'd like to thank everyone today for watching our training video, and I'd like to say a special thank you to Sub-Zero for supplying the under-counter refrigerator that made this video possible.
Well, thank you very much. And let me get back over here and stop this. There we go, right there. Okay, so that was those were very informative videos. I will tell you that since the production of that video, there have been several adaptations that have done. Now the low side and high side gauges are done with a manifold, just like it was whenever as you have your regular set of gauges. So those are brand new, and those are that's something that's happened since this video was put out. That is a very informative video. The one thing I want to get back to with you and stress is, if you noticed, he kept turning the gauge on, turning out the gauge off, turning the gauge on, turning the gauge off, letting whenever he's sucking refrigerant into the system. That way, you're sure that you get everything in the out of the system. I'm sorry, everything into the system from your hoses. Does anybody have any questions on what we have talked about so far? Please, if you do, put it down into the comments section. Okay, so we're going to talk about Lokring assembly tool training for your appliance repair. This is just kind of a tutorial that we're going to use. Once we get through here, we're going to talk about the pre-assembly tool and the cutter that is available from Lokring. Now, every single one of these parts that you need to be totally, you don't have to have all of these. There are other bags that are out there that you could use, but once again, this is a double bag, so you have a safety piece in there. I mean, if you look at it, Whirlpool back in the 90s had a bag that was very similar to this, but it wasn't double lined. It was just a single line valve. Those had a tendency to explode if you weren't careful. Last thing we want to do is to have our R600 leak or explode. So what will happen is, just like he said in the very beginning, was I want to take my bag, take it out where I can actually let the refrigerant out. I've got to have my area safe. You notice that every time, and he didn't come back and touch back on his snubber was actually clicking, but it wasn't turned on. He had it turned off so that you could hear. But that's very important that you have that snubber clicking, so that you make sure that you do not have a leak, or it doesn't detect any leak. Because, I mean, like we all know, even the light switch that you flip on and off can cause the reaction and be my spark that all it takes to make it into a flame. So let's go, and we're going to talk about our Lokring assembly tool. Okay, here is a picture of your assembly tool. There are two types of assembly tools, okay? This is the H Mark B, okay? That's the part number, okay? That is, the application is for refrigerated appliance and automotive, so you could use this if I was having to convert an R600 from a car. So it will accept from a 1.5 millimeter, which is basically a 1/4 inch tube, all the way up to a 10 millimeter, which is almost a 3/4. Okay, I have a lever mechanism. It's minimum effort. Both of the handles you can use either left-handed or right-handed. I am the opposite of most people. I am a left-handed person for something like this. So whenever I'm doing this, I'm going to hold this H Mark tool in my left arm with it extended, and that's why I'm going to use. And then on the right side, I am going to take and use and click through and get I'm going to click through it and press these fittings together. Okay. It has, 8 millimeter to 10 millimeter, like I said, a 5/16 to a 3/8. Okay. So one of the other thing is there are two different sets of jaws bends that you get with this. Okay. So I have one that's for the 3/8, and then I have the one that will go from the 1/4 all the way up to the 3/8. Okay. Then I have a ratcheting lever that I'm going to use. There's a fixed handle lever. So I have the ability to adjust either side, which makes it into a left-handed or right-handed piece. So once again, if I'm left-handed, it's showing you right here that my right handle with release levels on the back side of the tool. That's the side that I'm going to use. If I'm left-handed, which I am, I have a left-handed with the release lever on the front side of the tools. Okay. So as you notice right here, the right-handed and the left-handed. Once again, I'm using a pushing motion by the arrows, as you see with the arrow diagram there, and that way the jaws are fully opened. Okay. Once I do that, I've locked this tool into place. Okay. So the tool is fully open. The ratcheting handle back is against the fixed handle and shown to take my thumb and I hold that into place so that it doesn't move. Okay. Then once I do this, again, left-handed or right-handed, that's one thing that I like about this presentation. They show you both ways, because if it's me that's doing it, I'm going to give you the left-handed, and that's not really what 80%. I think it's about an 80-20% that are left between left hand and right hand people. Okay. Next, place your hand over the fixed handle and the ratcheting handle shown in gripping both sides. You can see it right there. Okay. Once I do that, I can use my other hand now to free up and hold the tubing together. This is what I keep telling everybody. Once again, it's your right-handed and your left-handed. So here's what I was talking about. You got a very good diagram of the one since I'm left-handed, I lay it right here. It lays in there just like it shows in the picture. Okay. And then I can hold the fitting with my two fingers right here. And if I have another one that I need to hold or steady, I can steady that, and then I can crank it by using the ratcheting jaws. Okay. So the various methods for holding the assembly tool, they're showing it right here. This is about everything that you could possibly need. I'm going to always try and preload the tubes so that the seat against the internal stop. Then I'm going to push the loose tube again against the fixed tube, such as the mounting evaporator, mounting it from the evaporator or from the compressor. So this is basically shows many of the issues that you would come with. So my tube connector assembly, okay, the first step is I've got to clean my tube. Okay, I'm going to clean this before I do anything else. Before I make my cut, I am going to clean all of this out. So what I do is I clean my joint where I'm planning to make the cut. I try to put it right in the center of where I'm going to cut. That way I've got it cleaned out, and I can have the whenever I make that cut, it's still nice and clean whenever I take it off. Well, the other thing that you need to be very careful of is that I need to use a set of. I'm highly allergic to what am I looking for? Um, uh, I have to use a nitrite glove. I can't use the one like everybody else, the almost clear glove. I have to use a nitrite glove, and the ones that I buy are gray or black, one of the colors. And that keeps me because I break out with I have a latex allergy. Okay, so that keeps me from breaking out. You use whatever works for you. You can buy your gloves um, at Encompass. Um, you can buy them anywhere that you want to buy them, but I'm trying to push you Encompass to you. So all of those tools that we have discussed and any of the other things that are out there. You can buy the snubber from Encompass. They have the exact same snubber as the one that he was using. Now, I will tell you this: you have to be careful whenever you're using the snubber and you're looking. You notice that whenever that video went and he was at the evaporator, okay, and he started to go across, you notice that at one point he actually kind of detected a leak, because what will happen is the snubber itself it goes tick 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 tick, and then as you detect, if you get closer to a leak, it speeds up and it goes tick 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 tick. And then once it gets and you get a leak, it stays. You get a solid, and you literally, it's very loud, and you have to silence it, and then you have to find it. And whenever I'm doing that, I can actually silence it and look at the gauge, because on that snubber there's a gauge that tells you whether I've got a leak. But the other way, it's very loud. You want to make sure that I'm using that through the whole process, because that tells me if I have a leak. If I don't want to have it so that I'm the guy that gets burnt or starts the fire. One of the guys that I trained was telling me about this R600. He had a technician that just actually purged the system he just went ahead and cut the tube. And he was a young technician, and he almost burned down the whole shop. They had a fire, and literally started to burn it started a fire and almost got the whole shop, and almost had to redo the whole shop. Okay, so I'm just telling you that you need to have it all the time so that my snubber is going off. The other thing that he never showed was, well, he did kind of show it at the very on one portion, was your fan. Okay, I actually have whenever I bought my set of tools, there was an accessory that was a fan. So for my drill, I can actually stick my battery into my fan, and while I'm doing everything else, my fan will continue to run. You've got to make sure that you have got, excuse me, you've got to make sure that I have no chance of having a flammability issue. Okay, so I want to make sure that I've got that done. Okay, the next thing, we're going to apply some lock prep. Okay, first, let me go back just a minute. There are actually two tools that you can use. You can use this H mark tool. Okay, that's the one that comes with the kit. They make a separate tool that turns this from a I've got a ratchet in and worry all this. it literally, there's a tool that is battery powered that I can do everything that I'm going to do, and all I have to do is mash a button and it will do everything else. If I'm going to be doing, whenever I was a technician, okay, and I was running basically 8 to 10 calls a day, and we're changing compressors. And if I had one of these, I would have loved that, because I don't have to. If with this other tool, all I have to do is make sure that I've got it all locked into place, and then all I do is mash the button, and the tool does it all for me. Now, that is an expensive tool, but you get what you pay for. I mean, I can tell you right now, if I can save 10 minutes on a job, and I've got 8 compressors that I'm having to change, or eight units that I know that I'm going to have a leak on, and I've got to go and find my leak and fix it, I'm going to take those 10 minutes and save those, because it benefits me. So is it a cheap thing to do? No, but if I've got the usage, I'm going to do it. I'm going to go ahead and buy this tool. All of these tools are available at Encompass, every single one. Okay. Lock prep. Let me tell you about lock prep. Okay. Please do not use lock prep that is over a year old. If you look at the bottle, you can see it right there. It comes with a date stamped on it. If I am going to use lock prep, it has got to be less than 1 year. If I try to use it and it's over a year old, there is no guarantee that that is ever going to work right. Now, I will tell you this. I actually like to take my lock prep, and I like to shake it a little bit before I put it on. Does it do anything? No, not really. But it tells me that I've got it all mixed up and I'm ready to go. Okay. So once I do that, I'm gonna apply my lock prep. Once again, there is a chart that comes with every single kit that tells me exactly how many drops of lock prep I need. The one thing I don't really understand is how I get half a drop. That's kind of a funny thing. You can't really get a half a drop. So yeah, you get a drop, or you get a drop. There are several that are like 2.5 drops. So, you just have to, I usually try to do I'd rather go have too much than too little. But as we get along into this program, you're going to see that we're going to get through. So, what does my lock prep actually do? Okay. So I don't know if you realize this, but every time, like, you take your sandpaper and you're cleaning your joints, you're going to actually leave a groove in that joint. So the lock prep is designed to fill all of those grooves and make it so that you get no leaks from it. Okay. That's why, if you noticed, he said you need to seat it fully into the unit to make sure that my lock prep and my joint is like it should be. From what I have seen, if you have a poor joint, okay, it's usually caused by the person. Okay, one of the things that they talked about was the filter dryer. Okay, this filter dryer, notice has the process stub on here. Okay, I can take this off, and now I've got my Schrader valve in there, and I now have it so that I can put this on, and I can use this Schrader valve. And if I'm done at the very end, one of the things that he was talking about was I can actually put a couple of drops into this Schrader valve. Not only that, I can take and put a few drops around the cap here. I can then at this point, I'm going to screw my cap on. Once I screw my cap on, this deems this so that you can't use it again. Okay. What the other thing that I really like about this is that this actually has the Schrader core remover right there. So I can take this, turn this upside down into my Schrader, stick it into my Schrader core, spin it, and it will actually take the Schrader core out. I want to be careful because I don't want to drop my Schrader core, because the last thing I want to do is lose my Schrader core and can't find it. Okay, so if you look at it right here, you can see that is actually, let me put this back on, tighten this back up. Whenever I get done, I want to tighten this. I always tighten it, not super tight, but just a little bit. If you, once again, he had a special tool that he could remove the Schrader core and it would click, and that would tell me that I had the correct usage that I had. Okay, so if you look at this unit right here, okay, there is a good seating one for aluminum. Aluminum, that's easy for me to say. Aluminum is the hardest to get the fitting correct. Okay, I can do it any day, all day long on the copper. If I go copper to steel, I'm good with that. I don't have any problems. The aluminum, you have to be very careful, because whenever I've got my fitting right here and I've got it in my arm and I'm cranking it down, okay, I actually have to be very careful, because it will actually mess it up, and I get a bad joint and I have to redo the joint. So the last thing you want to do is make it so that you have to cut your joint again and clean it. Okay. So here's what I was talking about. So I have to push each end all the way to the stop. Okay. So whenever I've got my H mark tool and I have my fitting, I have to put that in. I have to make sure that these two pieces are all the way to the stop. Once I do that, I'm going to tighten everything down. And once I get that, you will have this finished product. You can tell whenever I do this that I am all the way through the center by the center joint right there. Okay. Because there is an internal stop that is on every joint that you have. Okay. Right here is a picture of it. You notice right here how I'm compressing it now. Okay. So you see it. I've got it to the internal stop right there. Hang on one second. Oh, excuse me. I'm going to place the connector over the tubes halfway to the internal stop. Apply the lock ring to the tube where it meets the end of the connector. Then I'm going to push the two tubes together. Lock prep will be drawn into the connection by the capillary action. But one thing that it doesn't tell you is you have to at least turn my fitting. Once I have applied my lock prep, I have got to turn my fitting at least 360 degrees. Okay. I'm a guy that does it more than it needs to be. So I do it twice. Pardon me. It must be my allergies are picking back up. Okay. So I've just got to make sure that I've got to put I have my lock prep locked up put in, I spin it so that I get it distributed evenly, and then I'm ready to go. Okay, so I'm going to rotate the connector 360 degrees to help disperse the lock prep. Like I said, that's 360. I do it twice. I place the assembly tool over the connector ends. I'm going to slowly ratchet the handle to close the connector. I'm going to make sure the tubes are fully inserted into the internal stop. I use my 2 fingers to hold that connector so that it doesn't slip away. Okay. The tool to the connection is totally complete. Ensure that both the lock rings are seated against the center stop. Wait at least 10 minutes before applying a vacuum, and then I can pressure or radial force. I pressure test mine. Okay. So my lock ring capillary tube connectors, I have no internal stop into the capillary tube. So what I actually do, for me, you have to be careful of this, is how far in do you put it? Okay. If an aluminum tube is on either side of the production, an aluminum lock ring connector, you got to use the aluminum lock ring connector. Okay. For all other connectors, a brass lock ring connector is used. Okay. Following these following steps to make the lock ring reducer connector on a capillary tubing. Okay. Clean the tubes with the abrasive pad or memory cross using the radial motion. Okay. I use a 1/over. You notice that this gentleman has got it held, and he's moving it. He's just moving his tube, trying to run it through. I use what I call a double left. So what I do is I take, you notice where it's got the, hang on a second. Okay. So this is the end, and this is the one that's going to go into my tube. So I find which side I need to cut. I take, and instead of doing it one time, what I do is I literally take, give me 1 second here. Okay. So what I do is I take and place, this is on one side, I come under, I go over, and I come this way. And then this is the way that I sand, okay? I've got this connector all the way through. For me, it makes it so that I can do this. The gentleman right here is just taking it and doing one of these. I don't like that method. I like the double over method. That is something that you're going to have to, as a technician, you're the one that has to go and figure that out. Okay. So I'm going to pass the capillary tube in it all the way through the connector. Okay. I'm going to create a stop about how far I need to go in with that capillary tube. Okay. I'm going to create a stop by slightly bending the capillary tube. You have to be very careful, because I can pinch the capillary tube off, and then I have to redo it all over again. Okay. So once I do that, I'm going to insert the other tube into the connector about halfway for my internal stop. Once again, I'm going to take my lock prep, make sure that I have the new lock prep, and it's not in an old bottle. Okay, I'm going to apply the lock prep to the larger tube first, and then to the point where the lock ring connector meets the tube point, which is A. Then I'm going to put the capillary tube back approximately 1/8 of an inch from the stop bend that I have where I bent it. Okay, and then I'm going to apply 1 drop of lock prep to point B. Do not over apply lock prep to the capillary connection. Doing so may block the capillary tube. It is very easy to block a capillary tube. Whenever, like I said, I'm an old technician. I literally I'm the one that kind of taught taught the class, whenever there was a new technician I can't tell you the number of times that I had a technician using a torch that caused the capillary tube to not allow the refrigerant to flow through it because he put too much. His old the technician's old adage was, well, if I got a little bit, that's okay. But if I fill it up, I'm a whole lot better off. That's the reason you see a unit that you got the back of it, and you look at it and you can tell what the problem is, because usually he used way too much. Same thing here. If I've got a whole lot of lock prep, I'm going to be able to see that, and that's going to tell me right there where I probably am going to go to look to make sure that I don't have any problems. So once again, I have my 360-degree turn. Like I said, I do it twice, not once. Make sure that both the tubes are fully inserted to their stops. The capillary tube needs to be pushed all the way to the bin, okay? Then ensure that the connector is fully seated to the assembly jaws while I'm closing the connection. You see him doing that right there. He has his two fingers holding it in place, while I see that this gentleman is left-handed like I am. Okay? So I'm going to ratchet the tool till the connection is completely closed. You can see right there that he's got his hand on it. He's got one finger on both sides. Ensure that both lock rings are seated against the center stop. Once again, I have to wait for at least 10 minutes. Okay, so one thing you need to remember is, if I'm lock prep, whenever I have a black light and I'm checking for my lock prep, it fluoresces with a bluish color. And then if I have a leak detector, and I have used hang on just a second. If I use my yellow is going to be my leak detector. So that's your UV dye. I'm sorry. If you had a UV dye, that's the one that's going to fluoresce yellow. Okay, so lock prep fluoresces at a blue, so that I can check my connections that way. Okay, once again, you can see right here, that's the lock prep and the UV dye. Okay, does anybody have any questions? We're a little bit late, but you know what? I wanted to make sure that we got everything in here. I see that we only have one person left in the class, and the other two had to leave. I wanted to thank everybody. I really appreciate all that you do for our industry. I believe that as a partner, we need to have as much training as we can have. As a supplier, as a supplier for parts, Encompass tries to do everything that they can for you as a technician. They try to make everything just like it needs to be, and makes it easier for you as a technician. They understand that time is money. Okay, so have a great day. If you have any questions, my information is scrolling across the bottom. If you need anything, thank you, Kelly. If you need anything, send me a text, send me an email, either way, but I really appreciate it. And if you have any questions, like I said, don't hesitate to reach out to me. I'm going to ask that you watch this little presentation at the very end. It's about 1.5 minutes, so it's not that long. But have a great afternoon, and be safe out there.
Thank you.